Hello, everyone. Yes, my name is Boris Polania. I'm the lead DevRel for DevHub. That means that I deal with my team deals with all that is related with developers within the Near ecosystem. So I'm come to talk, as they just said, about chain abstraction. Forgive me, chain abstraction. It pays so much to the name. It can be a little, abstract, but I will try to make it easier for you to understand. So the main idea, the one I come to talk today, is about how to do cross-chain without breaches, right? How to move stuff, how to move assets between different blockchains. So that's the traditional approach to this is using bridges. And bridges, just a quick summary of how bridges works, is most of them, they lock, if I want to move, for example, a bridge between Bitcoin, I don't know, and Ethereum. So let's say one part lock Bitcoin somewhere, and there are some relayers that relay the information that the Bitcoins were locked in somewhere, and then they generate, they release the same amount of Bitcoins, but on the other blockchain. It's a little more complex than that, but that's the idea. You lock assets on both different chains, and then when you want to move from blockchain A to B, you lock here, release here, and then you want to go back, lock here and release here, or born here and release here. So that's the way it's been doing. It's still being doing like that. Still, there is a lot of activity on bridges, mostly on DeFi. Bridges for DeFi right now is important. It's the way to do DeFi. If you want to move assets, specifically tokens between different blockchains. So activity is still high. It's probably not as high during DeFi summer, but it's still high. But the cross-chain swaps also is still getting an important amount of money going there. But DeFi bridges are not enough. They have great challenges, the bridges. I can tell you myself, I was working with Harmony when they hacked the bridge I was working on, right? So they hacked $100 million. And Harmony is not the only one. Bridges are dangerous, and they are hard to maintain, very expensive to maintain. So as you can see, there is a large number of hacks on existing bridges. So there is not there is not enough support. I want to explain this to make clear. There are multiple bridges they can bridge among a specific amount of blockchains. There is not like universal bridge where you can go from one to one. There are bridges aggregators that can connect between these different bridges. But one thing that is not clear is that the cost of moving money on bridges is high. Not only the fees, but also the slippage is expensive, especially if you're moving money with Ethereum. It's really expensive to move assets using the bridges. So the fact that it's not a universal bridge, it means that if you want to move, I don't know, from some strange blockchain to Near, you probably have to go through a couple of bridges. So it's expensive. The fees are high, the time is high, and in that process, the risk of something happening with the funds are high. So there is definitely not consistent UX. What this means that the experience, you don't know if it will going to take seconds, it will take minutes, or take hours to bridge your assets. You don't know if, depending on the assets you're moving, you don't know if there will be the right liquidity over the process. So if it takes hours, you may be open to lose through leakage. So you may even lose more money just by waiting, and then you have to pay the gas for all the transactions. So that's some bridges manage that well, most of them not. So there is a lot of failure points when you can be losing money. So it's hard to know if you're moving $1,000 from bridge to blockchain A to blockchain B, how much money you're actually going to get. They will approximate it in the bridge when you're doing the swap. They will tell you you will get more or less this, but you don't know what exactly is going to happen. If it's a swap that takes hours, fortunately, the price of the tokens you're swapping will change. So you don't know for sure what is the final amount you will get after the whole transaction is done. So there are other approaches. One of the other approaches is near approaches, the programmable MPCs. I don't have it here, but I will try to explain a little what an MPC is. A multi-party computation is a group of entities of people agreeing on running a specific code, specific functions. Like we go together and we computate this specific code. That's what a multi-party computation is. It's more complex than that, but that's the general idea. So the programmable MPCs are MPCs that these algorithms that can be, updated or programmed to change over time. So what are the key advantages of these programmable MPCs? You can support all change, including those change that doesn't support smart contract natively. Is the way to integrate a new chain is just to deploy a new relayer, so it's instant. And you can have a standard user experience for every single cross-chain transactions using the programmable MPCs. So there are a few programmable MPCs in the market. NEARS is one of them. But Dfinity, Chainflip, Zetachain, Stacks, they're running programmable MPCs. There are two types of programmable MPCs. There is account-based, is that to be part of the, if you want to be part of the multi-party computation, you just link your account. You have an account, some kind of account system, and say, these accounts are going to be part of this computation. Or you have the deposit-based, is that basically you need to put some kind of deposit to be part of the computation. So these are the two approaches. NEARS approach is an account-based multi-party computation. So the core, the base of this is the chain signature. So the formal definition is that there are threshold signatures controlled by near accounts and smart contracts. What this actually means is that you can sign a transaction in near, you can start a transaction in near, and that will be completed on another blockchain. But the signature for the user, if I want to start a transaction, I will sign that transaction on near. And even more beautiful, you can pay the gas on near as a user. In the back, you will see there are relayers that you probably, as the owner of the process, you will have to put gas somewhere. But for the user, for the day-to-day user of your product, they can pay the gas in near. So there is a single user experience here. They don't have to pull the MetaMask. They don't have to do all that. You can even waive, if you want it, you can waive the gas. You can say, the user doesn't pay gas. I will pay the gas for them, and then I will charge them, I don't know, a monthly fee or later or whatever I want. Or you can get them to pay the gas, but they will have to pay it in near. They don't have to have, gas money for Ethereum or for Solana or for Bitcoin. They can have all the gas money on near. This sounds that, but this is very important because this is aimed to improve the user experience for all the users. So you don't have to have, your users can have a regular user experience. If you want them to pay gas, they only have to hold near, even if they are running transactions or in Bitcoin. I will show that later. Or even if they're running transactions on Ethereum, they can be just paying the gas on near. Or no gas at all. It's your decision, right? For Ethereum, it will be difficult to do that, but it's still possible. I mean, difficult because the gas in Ethereum could be really high, right? So the basic idea is you have a near account. The near account will, will sign the transaction. This means that you will pick up the network where they're going to send the transaction. Then you need to derive an account. I will talk about it a little, and then the message you're sending to the other. That's a signature send. The signature says, I'm sending this message to this account in other blockchain. And how you know the account, you have to derive it from your NIR account. So my NIR account will derive an account in other blockchain based on my NIR account, okay? So then we have a bunch of NIR validators that will start a multi-party computation for different blockchains, right? You can do it on Ethereum, Optimism, Bitcoin. So this is the general idea of how it works. And how do you do this? On the coding side is fairly simple. It's a single call. Well, once you install everything you install, in your code will be basically a single in the API call. I just want to sign this transaction. This is the payload. This is the message I need to send to the other network. I need to derive this key. It will depend on the network, and then depending on the network, you will find you need to select with type of signature is a CDSA, etc. So this, as simple as this, is the type of code you need to do from the coding side to sign a message or sign a transaction in another blockchain. So this is the general idea. This is the two parts of this, right? So you have a NIR account that would initiate the signature, and then there is a NIR MPC node. Imagine some kind of validators, and then they will send the payload via MPC to the blockchain that you decided you selected, right? It could be to Bitcoin, it could be to Ethereum, Solana, Atom, whatever is that you need to sign the transaction, right? And then you have the gas relayers. You will see this part is similar, right? But the difference here is that the relayers are the ones that are actually paying the gas. They will take the gas from whoever you said should be taking the gas. It will take it from the user. It could take it from you or a third party. Basically, the relayer are the ones signing the actual payload to the final blockchain, so they are the ones paying the gas on that. So you have to define some kind of policies from where the gas is coming. But you can completely say, okay, relayers, I'm paying the gas, the user doesn't pay anything, I'm just paying the gas. And then I deal with the client or with the user, so they don't have to pay gas. Actually, in some of the top 10 apps in all blockchains, a few of them run on NIR, like Sweat or DevHub. And these are apps that the users don't necessarily know they're running on NIR because they are completely abstracted. That's where it actually comes the abstraction part. We abstracted the transaction out of the gas fees payment. These apps decided to say, I will charge my user gas, I don't know, the monthly fee, like Sweat, I think, covers a monthly fee, so they don't have to pay the gas. I don't want them to open the MetaMask or to launch the wallet or add private keys. I don't want them to do anything. I just want them to have an account, a blockchain account, and I want them to use the app without actually having to deal with the whole blockchain thing. But at the end, all those transactions for apps like Sweat, they go into the blockchain. They are blockchain transactions. So these are, and then at the end, the relayers will make, as you see, the payment in USDC to all of the gas, right? In any of the target blockchains. So these are the two components of this. This is how we do, in general, the bridging without having to go to traditional bridges. So there are some use cases for this. Bridges cross-chain DeFi is the first that comes to mind, right? But I remember back in 2020, we were talking about cross-chain NFTs, right? That point seems like a little, especially when the frenzy craziness of the NFTs sound like a buzzword, but it makes sense, right? You need to be able to have non-fungible tokens and move it between chains the same way you do fungible tokens. If you should be able to move ERC20s, why not moving the NFTs? It didn't make sense entirely when the NFTs were like GIFs, like apes or something. But it makes more sense with the NFTs represent some other kind of values, right? Not necessarily images, right? Even so, it will work with the image, but it didn't have like a very use case. Why would I move my, I don't know, my NFT near to Ethereum or something like that? It doesn't make more sense for some people, but it's not the killer use case. But if this NFT represents other kind of assets, it probably makes sense to have it, moving between chains, right? So we also, one of the use cases of the chain signatures is the multi-chain account abstraction. It's the same as just described, that you can have abstracted accounts that they don't have to pay, the user doesn't have to pay gas. They are completely, the payment is separated from the transaction. It doesn't mean that the transaction doesn't pay gas. It means that the users doesn't have to pay gas. Trustless multi-chain deployment is basically you want to be able to deploy multiple chains and do it in a trustless ways. And it also helps with a lot of privacy-focused apps. But here, being this D3 conference, I will focus on the second point, right? DeFi and NFTs in non-smart contract chains. How we can handle DeFi, and in this case NFTs, in blockchains like Bitcoin. So I imagine this is, from now on, it's completely hypothetical. Nothing of this exists. But if I were to implement it, it will look like that. So I imagine a top-level domain called .dgen. You know what dgen means? Is decentralized generation. So imagine a .dgen TLD, and how will this could be implemented using a chain signature or chain abstraction. So imagine a seller and a buyer, and imagine there is D3 decided to set up a marketplace for people to be able to sell or buy domains, right? So the first thing that will happen is the seller generates a deposit account on BTC and send it to the marketplace contract. This means that this is all near. So imagine my near account, or is called Polania.near. I generate a Bitcoin account that is linked, is derived from my near account. So I generate it, and I send it to the smart contract, and the smart contract logs, okay, this is a BTC account that is linked to Boris' near account. Then the buyer, they make a deposit of USDC on near. Then the seller deposits the actual, they own, we're assuming they own the domain, so they have their own, the seller.dgen NFT that proves their ownership of that domain, and they deposit the NFT in the BTC account. This still is a BTC account derived from a near account, so it's still a near, right? And then the seller lists the NFTs and say, okay, I'm selling this for USDC. The buyer accepts the listing. So at this point, the seller received the 10 USDC, and the buyer received the control of the BTC account. At this point, they will get control of the private keys of a BTC account that they will be able to access through the BTC network. So this will be the loop of how, using chain abstraction and chain signatures, you will be able to breach this. What is happening here is just breaching this NFT that is representing the top-level domain. You are bridging it from the seller to the buyer, from near, or from whatever it was. I'm assuming seller was in near, but it doesn't have to be initially near, and move it through Bitcoin. So as you see, it's not follow the traditional bridge format. Like, we are not locking assets in one chain and to release it or burning and stuff like that. It's just using chain abstraction and being the possibility of being able to sign transactions from another blockchain from near. So, a little DevHub. If you want to integrate this, if you are interested in integrated on why we're doing what apps like Sweat, DevHub, and all these guys are doing in Near, and how they're able to abstract and get this high level of user experience for the users. Come to us, we can help you with that. And if you want to take a look, just, there's the documents, the Telegram group. We are already integrating, multiple projects, and we're happy to help if you want to interested in this. So I think that's it. I don't know if you have time for questions. We do a question or not. If not, I will be around a little. And yeah, thank you very much.